Okay, so let us continue where we left yesterday. Yesterday we did up to question number 18. So today we are going to start from question number 19. So in question number 19, the question is very simple. It is from heredity and variation. And the question goes like this. Pea plant with red flower, capital R, and white flower, small r, are cross-pollinated firstly and then self-pollinated. What will be the color of flower at first and second generation? Why? Right with necessary chart भनेको यसमा चाहिँ हामीले we should make chart also, plus we also should explain why the color are different in F1 and why the colors are different in F2. So we should explain the chart as well. Okay, so let's begin. So first I have made a chart for you. So I think everyone knows how to make this chart, so but also let me explain again. So in the first generation we have two pure breed. Okay, so this flower is pure red and this flower is pure white according to question, right? So we all know that red is dominant character, red is dominant, whereas white is recessive character. So since red starts with R, so we are writing capital R for dominant character, and we're writing small r for the recessive character. Now after that, these are the parents. Now this is the genotype, the genes makeup. Okay, and then now we all know that capital R can produce two kind of gamete, that is capital R or capital R. Small r can also produce two kind of gamete, small r or small r, and these are the gametes which are formed, okay, by meiosis cell division. After that, now these gametes will cross pollinate, and for that we should use the laws of multiplication of bracket. First we will multiply the first gamete with the first gamete. So capital R multiply small r, so capital R comes from here, small r comes from here. So this is capital R, small r. This is the first offspring. Now again let's multiply the first gamete of the first parent with the second gamete of the second parent. Okay, so यहाँ first parent को capital R आउँछ, यहाँबाट चाहिँ small r आउँछ हैन. So we have got capital R, small r. Now let's multiply second one with first one. Okay, so second one gives capital R, first one gives small r. Finally let's multiply small one, second one with second one, so capital R, small. In this way we have got all the offspring same. We have got all hybrid and hybrid. So these are the offsprings of F1 generations, and they are 100% hybrid red in color. Okay, so this shows that in the first generation always the dominant character wins. So all the flowers are red here. There is no any white flower produced because white is the recessive character. Okay, so this is the first law of Mendel. Okay, so now again for second law, what we can do is we can take any two offsprings among these four offsprings. So we have taken this one, this first one, and we have taken this third one, so you can take any one. Okay, so again this first offspring gives capital R and small r because it has got capital R and small r. This third one also gives capital R and small r as gamete. Now again we have to cross these four gametes like using the previous rule, first with first with second with first, second with second. Finally we will get one pure red, we will get these two hybrid red, and we will get the last one as pure white. So this shows that we have got all the different kind of colors in the second generation. Okay, now let's give the region. Why there was 100% red in the first generation and why there are different color in the second generation. So let's explain this with region. Okay, so I have first. Okay, the first region is let's talk about why there are all red in the first generation. Why all the offsprings are red. So answer हुन्छ, in the first generation all the offsprings will be hybrid red किन भन्दाखेरि as only one character can express itself when there is a crossing between two pure contrasting characters भनेको. And we all know that the father was also pure red, the mother also was pure breed, pure white, and these were contrasting colors. So because of this only one color can win. Okay, so in this case the red color has won, so all the babies are in red in color. So that explains the first region. Now let's go for second generation. In second generation we have got one pure red, we have got two hybrid red, and we have got one pure white. Sorry, here is white is missing, one pure white flower किन भन्दाखेरि because the main reason for this is the offsprings of F1 भनेको यिनीहरु छ नि, these four offsprings of F1 which are all hybrid. We know these hybrids have got two kind of characters. One is dominant character, one is recessive. Like this you can see this one, capital R, small r. Capital R is dominant, small r is recessive, and these two characters they are together in this gene, but they don't mix up. They never mix up. They remain together for a long time, but they never mix up. And during the formation of gamete, these characters will separate. Like capital R goes to one gamete, small r goes to the other gamete भनेको यसरी फरक क्यारेक्टर्सहरु, कन्ट्रास्टिङ क्यारेक्टर्सहरु चाहिँ फरक ग्यामेटमा यसरी छुट्टिनु भएको हुनाले नै दिस रिजल्ट हैज कम. यदि यिनीहरू यसरी सेपरेट नभएको भए this result would not come. So the main reason for these different colors, pure, hybrid and pure, is that the hybrids of F1 generation, they produce the gametes which are pure. That means the gametes contain, some gametes contain dominant character, some contain recessive character. That means they contain both kind of characters in separate gametes. So this is the main reason that we have got pure red, hybrid red and pure white. So this explains the second answer also. Okay, so I think we are done with this question. Let's go for number 20. In question number 20, the question has asked us to make the picture of larva of silkworms. So questions are, draw the diagram of larval stage of silkworm and label the parts: thoracic true legs, spiracles, abdominal pseudolegs, and dorsal horn. So I got this picture from Google, so you can search it in Google as well. Okay, so this is the structure of larva of silkworm. So there are 13 segments. You can count 1, 2, 3, 4 from starting to ending. There will be 13 segments. And in the app, and this one is chest, so this is thoracic, this is called thorax. And the legs present in this thorax, there are 3 legs, 1, 2, 3. These legs are known as thoracic legs. And this one is called abdomen. Okay, this long one is the abdomen. And in the abdomen you can see you have 4 legs, 1, 2, 3, 4, and these legs are called abdominal legs. Okay, and similarly these small pores through which the larva can breathe, through which the larva can exchange the gases. These small pores are called spiracles. They are like our nose. They help the larva to breathe. Okay, in the same way we have got here one more leg. This is called caudal leg, or we also can call this dorsal leg. This is dorsal. So we have got two kind of things: ventral, dorsal. Ventral भनेको चाहिँ चेस्ट पट्टिको भयो. For example, यदि हाम्रो जिउमा कुरा गर्ने हो भने, like हाम्रो our face is ventral, our chest is ventral. Okay, but our backbone is dorsal. Dorsal भनेको पछाडी हुने हैन त. So caudal leg भनेको पनि dorsal leg हो, पछाडी हुन्छ यो. Caudal horn भनेको पनि यो पछाडी हुन्छ हैन. So तर क्वेशनमा चाहिँ हामीलाई के भनेको छ भन्दाखेरि we have to show only dorsal horn. So dorsal horn भन्नु र यो caudal horn भन्नु same हो. So caudal horn, so you have to show here dorsal horn, अनि caudal leg देखाउनु पर्दैन है. So this is extra. So this is the picture है. So now let's go for question number 21. In question number 21, the question is from Optics for 4 marks. Question is, draw a ray diagram of an image formed when an object is placed at a distance of 20 cm from a convex lens, having focal length 20 cm. That means in this picture, first we have to make a convex lens, and in this convex lens, the focal length must be 20 cm. But we know 20 cm is a very big number. We cannot adjust it in our paper exam sheet. So in place of 20 cm, we have to take 2 cm. So while I'm like, so let us take the scale of 10 cm भनेको चाहिँ हामी 1 cm लिन्छौँ, 20 cm को हामी 2 cm भनेको हामी एउटा 0 लाई चाहिँ up and 10 गरेर काट्छौँ अनि we will take only the remaining value. Like 10 cm दियो भने 1 cm, if there is 40 cm, we will make 4 cm है. So हामीले सुरुमा यो लेख्नै पर्छ, कुनै टिचरले चाहिँ लेखेन भने समास काट्ने गरेछ है. त्यही भएर first let's mention this always है. After that, now you can see here focal length पनि 20 cm छ. And the distance of the object 20 cm. It means that since the focal length and distance of object is both equal, the object lies at the focus. You can see in the picture here. Our focal length 2 cm, object 2 cm नै परछ. त्यही भएर जहाँ फोकस छ त्यही ठाउँमा के हुन्छ त object पनि सँगै हुन्छ हैन. So this is the object. So प्राय हाम्रो एक्जाममा आउने त्यही हो कि त फोकसमा भएको object आउँछ कि त 2f मा आउँछ. अस्तिको पहिलाको क्वेशनमा हाम्रो 2f मा थियो, अब चाहिँ फोकसमा छ है. So now we all know when the object is in focus, we have to use very simple rule, that is parallel focus O. So हामी पहिला यो लान्छौँ parallel, this is going parallel, and when it hits the convex lens, now we have to pass it through focus like this, and now we have to go through O. O is the optical center, it is here. O. Now we can see these rays are parallel, the reflected rays are parallel, and they are never going to meet even if we produce them for a long time. So this shows that these two rays can meet only at a very far place in which we can never reach. That means they are meeting at infinity. That means the image is formed not in our paper, but it is formed at infinity. So that means the image is, so I've written over here, the image is formed at infinity, and this image is real. Why it is real? किनकि जुन image चाहिँ लेन्स भन्दा उता बन्छ, राइट साइडमा बन्छ, they are all real. Okay, so this is also real. यो real नै हो. Real भन्नु बित्तिकै it is inverted. हुन्छ यहाँ हामीले inverted देखेको छैन पिक्चरमा. त्यही पनि obviously real भन्नु बित्तिकै के हुन्छ आफै, it is inverted. So real भएपछि inverted भइहाल्यो, and it is highly magnified किनकि when image is formed very far, 100% देखि हुन्छ त भन्दाखेरि it is highly magnified. So real भयो, inverted, highly magnified, formed at infinity. So these are the four nature, and you have to mention only two nature. Question we have to write the two nature. So you can choose any two nature. Okay, so let's choose real. I think real is easy one. Let's choose real and inverted. Okay? After that, questions are calculate the magnification of the image, and it is very simple. We have to use 1 upon focal length. यहाँ मिस्टेक भएछ, मिस्टेक भएछ. सो मैले यहाँ फर्ममा रङ लागेको जस्तो लाग्यो है. सो लेट मी करेक्ट. मैले यहाँ अर्कै निकालेको छु, पावर निकालेको छु मैले. क्वेसन चाहिँ म्याग्निफिकेसन है. सो पावर लाउनु पर्दैन है, म यसलाई करेक्सन गर्छु. सो इन दिस क्वेसन वी हैव टु फाइन्ड द म्याग्निफिकेसन, and to find magnification we know our formula is we can write image distance upon, we can use image distance upon object distance, right? तर यसमा पनि अलि मिल्दैन, त्यो पनि मिल्दैन. let's use त्यो लाग्दैन के फरक पर्दैन, त्यो लगाइदिनु ल. we can use here image distance upon object distance. okay, अब यहाँ के आउँछ भन्दाखेरि, so image distance भनेको it is very far, so it is infinity, right? It is infinity. So I have to find the symbol of infinity. Symbol of infinity यहाँ छ कि छैन म चेक गर्छु है. It is here. So infinity upon and object distance 2 दिएको छ यहाँ, you can see. So infinity upon 2, so infinity upon everything is again infinity है. So answer के आउँछ भन्दाखेरि यसको आन्सर हुन्छ infinity. Infinity भनेको it means it is highly, यसलाई मैले लेख्छु, infinity भन्नु र एकदम ठुलो भन्नु सेम हो. It is highly magnified है, त्यही भएर it is infinity. So this is the answer. Highly magnified भनेको infinity हो हैन, undefined. Okay, so this finishes the second part also. Let's go to our next question है. नम्बर 22 मा हेरौँ अब. So we have got a picture of lab preparation of a gas. So we have to first identify which gas is being collected in the gas jar. Question sir, which gas is collected in the gas jar? Obviously we have only two gases in class 10, ammonia and carbon dioxide, and this one is carbon dioxide, because in this case यहाँ heating पनि छैन, यहाँ heating पनि गरेको छैन, अनि gas जार पनि सुल्टो छ. This is 100% carbon dioxide gas हैन. After that, question sir, this gas cannot be collected by downward displacement of water. Why भनेको, this question has got two part. Okay, first part sir, why there is no downward displacement भनेको, why this gas jar is erect, why this gas jar is not kept inverted. So the reason is very simple, because we know the gas carbon dioxide, it is heavier than the air. यसको मतलब के भन्दाखेरि यो चाहिँ हेभी भएको हुनाले it always tries to go down, it always tries to settle down है. त्यही भएर हामीले यदि यो ग्यास जारलाई हैन, मैले घुमाइदिन्छु ल, यदि हामीले यो ग्यास जारलाई यसरी उल्टो राख्यो भने के हुन्छ भन्दाखेरि यो ग्यास यहाँ कलेक्ट भएको ग्यास चाहिँ तल जान खोज्छ, तल गएर यहाँ तल पुगेपछि यहाँ त खाली छ, यहाँ त ग्यास, यहाँ त केही पनि कर्ब छैन, यो तल झर्छ, तल झरेर यतैबाटै भुइँमा पुगेपछि ग्यास जान कलेक्ट हुँदैन. I mean the gas will settle down and it will not remain at this place, okay, in the gas jar हैन. त्यही भएर हामीले यसलाई सुल्ट राखेको राम्रो हैन. त्यही भएर यदि हामीले यसलाई यसरी सुल्ट राख्यो भने चाहिँ यो ग्यास चाहिँ यहाँ मुनि नै बसिरहन्छ हैन, हेभी भएको हुनाले. ओके, फर्स्ट रिजन. सेकेन्ड कुरा छ वाटर. Why there is no any water inside this gas jar? So it is very simple, because if we put water in here, the CO2 gas which we are trying to collect, it will react with the water, because we know that CO2 gas can react with water and it will form carbonic acid. It will form H2CO3. So I can show you the reaction also. So I think reaction मैले यहाँ देखाएको छैन, मैले देखाएको रहेछ. So let me show you the reaction. CO2 gas which we are trying to collect plus the water which can be inside the gas jar. योबाट के बन्छ भन्दाखेरि it forms H2CO3, that is carbonic acid. यसरी carbonic acid बन्छ, and that means in place of CO2 gas we are getting a different thing, that is acid. Okay, so our experiment fails. So we should never put water in the gas jar. Now let's go for number 3. Question samro, how can you manufacture urea from the gas collected in the gas jar? By using this carbon dioxide gas, how can we produce urea? And we know urea is a fertilizer, it is a nitrogenous fertilizer. Okay, so कसरी बनाउने भन्दाखेरि एकदम सिम्पल छ. We have to heat carbon dioxide gas and ammonia gas in the ratio 1:2 भनेको एक भाग लिन्छौँ हामी यहाँ. 1 is hiding here, you can see here is 1 is hiding here. एक भाग लिन्छौँ हामी CO2, हामी 2 भाग लिन्छौँ ammonia, and when we heat it at temperature of around 1500 degrees Celsius, it will form urea, and formula चाहिँ मैले घोक्नुपर्छ NH2CO NH2. So this is the formula of urea, so you have to memorize this. This can come in exam also. NH2CO NH2. Okay, plus water त obviously बनिहाल्छ हैन. So, and I have explained the reaction here by heating carbon dioxide and ammonia, and these are the two gases which we have learned in class 10. So हामीलाई घोक्न इजी छ यो हैन. At 1500 degrees Celsius, the ratio 2:2. अब यहाँ 1:2 भने उल्टो भएछ फेरि यहाँ पनि. धेरै मिस्टेक भएछ आज. 1:2. So we have to use here 1:2. Okay, so this is the answer. Let's go for question number 23 now. Question sir, how does blood play an important role in the context of control and protection? That means we all know that blood has got so many functions in our body, and among these functions, the most important one is control and protection. That means blood can control certain things in our body, and blood can protect the things. So how it does? So I have given example here. I have given 2 points here. The first thing is WBC. We know that blood contains WBC, and these WBCs can produce antibodies, and antibodies can easily fight against germs, okay, and different kind of foreign particles. So WBC, which is in our blood, produces antibodies, and this helps to fight against disease also, and germs, and different kind of foreign object. Okay, that's the first role that blood can play. Second role is the platelets, which are also found in the blood. They help in the clotting of blood. The blood can get thicker and clot. Okay, and during injuries, when we have got a wound, and by doing so, the bleeding can stop. So if the bleeding stops, then we can save our blood. We will not lose the blood, and we can protect ourselves. Okay, so in this way, WBC and platelets, which are the components of blood, they help to control and protect us, you know? So now let's go for the next point. Suggest any two precautions to be taken to reduce high BP. That means when we have high blood pressure, what are the things we should not do? So yeah, questions precautions भनेको चाहिँ what we should be very careful about, हैन त? So मैले अहिले आएको छु, number 1 we should avoid smoking. We should not smoke. We should not take alcohol, and we should avoid fatty, oily, and spicy food. Okay. Second, sir, we should avoid hypertension भनेको. We should not take too much tension. We should not take too much stress. Okay. Now, last question I think for this topic. Question छ हाम्रो यहाँ, how do industrial gases cause acid rain? So हामीले पहिला नि गरेको हो कर्नल गासमा हैन. So एकदम simple question छ यहाँ. The first thing is, you know that industrial gases भनेको, they are the gases produced by the industries, and the main gas that is produced by industries, CO2 gas, right? So when the industrial gas like CO2 gas react with the rainwater, right now it is raining here also, okay? So when it reacts with the rainwater, it forms dilute acid. For example, you can see here, you can see this reaction. CO2 gas comes from the industry. H2O is in the water, rainwater, and when they react, it forms an acid. This acid is called carbonic acid, but this acid is not pumped, it is dilute acid, and this acid falls down with the rain, and this is called the acid rain. Okay, our questions are, bro, effects. What are the effects of industrial gas? One much for, they cause ozone layer depletion, because we know that the chlorofluorocarbon and SO2, NO2, they can cause ozone layer depletion, and they also can cause over greenhouse effect. There will be too much hot temperature in the earth. Second, so they cause negative effect on human health. They can cause gum, asthma, lungs cancer, etc. Okay. Similarly, they can cause growth retardation in plant. They will block the stomata of the plants, and the plants cannot breathe properly. And when the plants cannot breathe properly, they cannot produce food. Without food, they cannot grow. That is called growth retardation in plants. The last point, they can cause accidents by forming industry smoke. That means industry smoke. This is the smoke which is very much white in color, very much thick, and it can cover the entire city. It can cover our vision. Okay, and because of this, the planes cannot land properly, and the cars vehicles may crash with each other. Okay, so this way it can cause accident. Okay, so with this, I think we have finished our set. Okay, we have finished our set, and so our I am preparing our next set also from Paption. Okay, I am preparing the next set from Paption, 2074, I think. So we'll talk about this in our next class. Okay, so आजलाई यति गरिदिउँ, पानी नै पर्दा छ यहाँ हैन. So let me stop the recording here.